Germany built some of the most feared tanks in history. It also built some of the worst. A tank that froze before it reached the enemy. A tank that could not cross a bridge. A tank destroyer sent to Kursk without a machine gun to defend itself. These were not accidents. They were approved, funded, and mass-produced, often after the army had already documented exactly why they would fail. This is not a story about bad engineers. This is a story about what happens when politics, ego, and impossible deadlines replace engineering judgment. 14 vehicles, the same mistake, made 14 different ways. Neubaufahrzeug, Germany's propaganda armor. It begins before the war, in 1933, when Germany began development of the Neubaufahrzeug, a multi-turret heavy tank concept that by 1937 the Wehrmacht had already internally decided was too cumbersome, too complex, and insufficiently protected to be worth fielding in combat. The decision to abandon it came before a single vehicle had fired a shot in anger. Only 5 were ever completed. And rather than scrap them, the army shipped 3 prototype vehicles to Norway in April 1940, not because they were combat effective, but because their presence in newsreel footage was useful. On April 22, 1940, one NBFZ sank into a Norwegian swamp near Åndalsnes during movement and was blown up by German engineers to prevent capture. The heaviest German tank of the period, destroyed by terrain. British infantry armed with Boy's anti-tank rifles, a personal weapon, penetrated the armor repeatedly. The survivors were scrapped in 1941, 9 years before the war ended. The program had produced nothing except experience and 5 pieces of expensive, unusable equipment. What followed the NBFZ was not a course correction. It was the same mistake, made smaller and faster. Panzer I, the training tank that went to war. The Panzer I entered production in 1934 as a training vehicle, not a combat vehicle, a training vehicle. Armed with 2 7.92 mm machine guns, armor 13 mm thick, and a 57 horsepower engine that overheated so routinely the design required mid-production revision before it ever left Germany. In the 1936 Spanish Civil War, Panzer IS encountered Soviet-supplied T-26 tanks and were outgunned in every engagement. The Wehrmacht documented those results formally. Then it sent the Panzer I to Poland in 1939, where approximately 320 of the 973 deployed were lost, many to Polish 37 mm anti-tank guns that had no difficulty whatsoever penetrating the hull. By June 1941, during Operation Barbarossa, 172 of 337 deployed Panzer IS were lost within the first month. Not to superior armor, but to anti-tank rifles and artillery, the tank was never designed to survive. The army knew what it was. It sent it anyway, because the replacement was never ready on time. The Panzer II arrived as the answer to that problem, and it was not an answer. Panzer II, the stopgap that became the standard. Designed in 1934 as an explicit stopgap while the Panzer III and IV programs developed, the Panzer II had become the most numerous German tank at the start of the war, with 1,226 in service by 1939, because the programs it was meant to replace had fallen behind schedule. Its 20 mm main gun had poor anti-tank performance against anything beyond 1939-era light vehicles. Its 14 mm armor was designed to stop machine gun fire, a standard the Spanish Civil War had already proven insufficient 3 years earlier. The AOS F, D, and E suspension variants, built in 1938 and 1939, performed so poorly in cross-country movement that vehicles had to be transported by heavy truck, overloading the trucks and causing damage in transit. By early 1942, the Panzer II was outgunned by every major Allied and Soviet tank it encountered, including ones it had fought since 1939. Germany deployed roughly 1,000 of them in each of its three major campaigns, Poland, France, and Barbarossa, accepting identical tactical limitations each time. Rather than accelerating the production of the medium tanks the Panzer II had been built to temporarily replace. While the Panzer II was failing its way through three campaigns, something stranger was happening in the design offices. VK 45.01P, the Porsche Tiger that drained Germany's copper. Ferdinand Porsche began work on his Tiger prototype in 1941, using a gasoline-electric drivetrain that required quantities of copper that Germany could barely supply even for its U-boat construction program. The Tip 101 engine failed almost immediately during early trials. A second engine lasted approximately 100 kilometers before failure. The Army recorded that performance degradation began as early as 50 operating hours. Despite these documented failures, Hitler ordered production of 100 hulls on April 20th, 1942, his birthday, before comparative trials against the competing Henschel design were even complete. The decision was based on his personal relationship with Porsche, not on any engineering evaluation. In November 1942, after final trials confirmed the design was unfit for combat, the Army canceled the Porsche Tiger. 91 already completed hulls were repurposed into the Ferdinand tank destroyer, a second vehicle with its own severe engineering failures, rather than scrapped. The VK 45.01P consumed strategic copper, required engine technology Germany could not sustain, and produced zero combat vehicles. Those 91 chassis became the Ferdinand, and the Ferdinand became its own category of failure. Ferdinand, the tank destroyer that couldn't defend itself. The Ferdinand was built on those 91 rejected Porsche hulls in 3 months, from February to May 1943, a production schedule so compressed that regiment commanders later reported crews had no adequate time to familiarize themselves with their vehicles before being sent to Kursk. The original design shipped without a hull machine gun. Soviet infantry approached immobilized vehicles on foot, attached magnetic mines, and destroyed them without the crew having any means of response. On July 5, 1943, the first day of Operation Citadel, the 653rd Heavy Tank Destroyer Battalion reported 37 of its 44 Ferdinands immobilized within the opening hours, primarily from mine damage and mechanical failure, rather than direct enemy fire. Towing a broken-down Ferdinand required 5 Bergpanzer 4 heavy tractors working in tandem. Any Ferdinand disabled in enemy territory was a permanent loss. Of the 91 built, roughly 50 survived Kursk. The remaining 48 were sent back to the factory in January 1944 for modifications that included adding the machine gun that should have been there from the beginning. The Panther was Germany's attempt to answer the T-34. The answer arrived broken. Panther AUSFD rushed in, broken down. The Panther AUSFD entered production in January 1943 with 45 documented mechanical deficiencies identified during field tests, including critical failures in the drivetrain, transmission, fuel, pumps, and engine. General Heinz Guderian warned Hitler personally in May 1943 that deploying the Panther at Kursk before it was mechanically reliable was tactically senseless. Hitler dismissed the objection and ordered deployment. On July 5, 1943, 16 Panthers broke down before reaching the front line from the rail disembarkation point, without firing a single shot. By the end of the second day at Kursk, only 40 of the original 200 Panthers were still operational, most losses attributable to mechanical failure rather than enemy action. The Panther's final drive had a rated service life of approximately 150 kilometers under combat stress. The operational readiness rate never exceeded 16% at the end of July 1943, rising only to 37% by December, a figure the Army described internally as wretched. At least 3 Panthers at Kursk were total losses from engine fires caused by their own fuel systems before making any contact with the enemy. The AOSF A and G variants were supposed to fix what the D had broken. They did not fix enough. Panther AOSF A and G, fixed on paper, broken in the field. The later Panther variants were produced to correct the AOSF-D's catastrophic reliability record. The AK-7-200 transmission, the Panther's most persistent failure point, still failed in over 90% of vehicles within 1,500 kilometers of operation. The turret drive was powered by a takeoff from the main engine so weak that full traverse on even a mild slope required the driver to redline the engine, and the gun could not hold its position on any incline. Germany produced 6,000 Panthers across all variants, making it the most produced vehicle in the German heavy armored arsenal. A vehicle whose fundamental mechanical problems outlasted every incremental modification applied to it, from its first day of combat in July 1943 to the last months of the war. If the Panther was the tank Germany built to win the war, the Tiger I was the tank Germany built to look like it was winning. Tiger I, 300,000 man-hours for a tank that couldn't stay running. The Tiger I required 300,000 man-hours to build, at a cost of 250,000 Reichsmarks, 2 to 3 times the price of a Panzer IV. Germany could produce 4 Stu-G assault guns for the cost of 1 Tiger. The first combat deployment in August 1942 near Leningrad ended with all 4 vehicles knocked out, not by armor penetration, but by terrain and mechanical failure before any decisive engagement. The semi-automatic gearbox was so mechanically complex that poorly trained crews routinely destroyed transmissions through misuse, and the vehicle required another Tiger to tow it when it broke down, since no other German vehicle was capable of the task. Only 1,347 Tiger IS were ever built across the entire war, a number so small that even extraordinary kill ratios could not compensate for its absence across a 2,000-mile front where Germany needed both quality and quantity, and could only afford to deliver one. The Panzer III sat in the middle of all of this, a vehicle designed for a war that changed while it was being built. Panzer III, designed for a war that changed. The Panzer III was Germany's primary tank killer concept through the mid-1930s, but its early variants shipped with a suspension and drivetrain that military historians consistently describe as tremendously unreliable throughout its first years of operation. When German crews encountered the T-34 in June 1941, the Panzer III's 50mm gun could not reliably penetrate the Soviet tank's sloped armor at combat range, while the T-34's 76.2mm gun could defeat the Panzer III from distances the German vehicle could not return fire. The Army's internal conclusion after the summer of 1941 was immediate. Production of the Panzer III should taper off. That conclusion, formally reached, still took until August 1943 to actually halt production, nearly 2 years after the problem was confirmed. Germany produced over 5,700 Panzer III's, knowing from 1941 onward that the fundamental design was outmatched because the replacement programs could not scale fast enough to fill the gap the Army had already acknowledged existed. Also inherited, also insufficient, were the two Czech designs Germany pressed into service after the occupation of Czechoslovakia. Panzer 35T, the tank that froze. Germany pressed the Czech LT Vizu 35 into service in 1939, redesignating it the Panzer 35T. It weighed 10 tons. Its pneumatic steering and braking systems seized and failed in temperatures below freezing, exactly the conditions Germany would face in Russia. During Operation Barbarossa in the winter of 1941, Panzer 35Ts froze consistently across entire units, rendered non-operational not by enemy action but by temperature. Germany fielded 160 of them at the start of Barbarossa, knowing from French campaign experience that the design had reached its structural limits. The hull could not be modified to carry a heavier gun or more armor without catastrophic overstress. They were deployed anyway because replacements were not available. Its successor in the Czech lineup did not fare much better over time. Panzer 38T, the design that outlasted its usefulness by 2 years. Germany inherited the Czech LT Vizi 38 and produced 1,400 units as the Panzer 38T, a vehicle with 25 mm of frontal armor and a 37 mm gun, specifications the German Army knew were inadequate for medium tank combat by the time Barbarossa began in June 1941. By mid-1941, the Panzer 38T's armor could be penetrated by the Soviet 45 mm anti-tank gun at all combat ranges, and its main gun could not reliably defeat T-34s or KV-1s from any distance. Production continued through 1942 because Germany had no alternative. The chassis was eventually repurposed for tank destroyers and self-propelled guns, producing more useful equipment in its second life than the original tank had in its first, which is the clearest possible engineering verdict on a vehicle Germany deployed for 3 full years past the point it knew the design was obsolete. The Tiger II was the Tiger I made heavier and given the same engine. Tiger II, more tank, more problems. The Tiger II weighed 68 tons and used the same Maybach HL230 engine as the 57-ton Tiger I, making it chronically underpowered from its first day of production, unable to reach its designed maximum speed under most field conditions. Only 492 were completed against a planned order of 1,500, with Allied bombing of the Henschel factory at Kassel eliminating a significant portion of the projected output. The operational readiness rate averaged below 40% throughout its service life, with the engine and drivetrain consistently unable to sustain the vehicle's own weight across anything but ideal terrain. During the Battle of the Bulge in December 1944, Tiger IIs were so mechanically fragile and fuel-hungry they were kept at the rear of columns and participated minimally in the offensive they were specifically committed to support. Germany ordered 1,500 and received 492. The Soviet Union ordered IS-2 heavy tanks and received nearly 3,900. That production disparity is the engineering failure that mattered most. If the Tiger II represents mass that could not move, the Jag Tiger represents what happens when that logic is pushed one step further. Jag Tiger, the heaviest tank destroyer ever built. The Jag Tiger weighed 72 tons and used the same engine as the Tiger II, which was already overstressed, powering a vehicle 15 tons lighter. The Army documented this mismatch before production began and accepted it anyway. Germany ordered 150 and received between 70 and 88. In mid-February 1945, all operational Jagdtigers were ordered to halt movement entirely because their mechanical unreliability had made any tactical deployment counterproductive. Of the Jagdtigers on the Western Front, only 20% were lost to enemy fire. The remaining 80% were abandoned by their own crews due to engine breakdown, fuel exhaustion, or transmission failure, a ratio that tank commander Otto Carius described as making full battlefield potential impossible. Recovering a disabled Jagdtiger required one Bergepanther plus 2 heavy prime movers working simultaneously, making battlefield recovery so logistically impossible that crews routinely destroyed their own vehicles rather than attempt it. Its 128mm gun required 2-part ammunition assembled by 2 loaders per shot and had to be locked in a travel position during any vehicle movement to prevent mounting bracket wear, meaning the gun could not be fired immediately upon halting. And then, at the very end, there is the Maus. Panzerkampfwagen 8 Maus, the tank that couldn't cross a bridge. Ferdinand Porsche presented the Maus concept to Hitler in June 1942. The first prototype was tested in December 1943, 6 months after the Battle of Kursk had ended and Germany had moved to strategic defensive. The vehicle weighed 188 metric tons, more than 3 times a modern M1 Abrams, making it physically incapable of crossing any standard military bridge on any European front without dedicated engineering support that would have announced its position hours in advance. The MB517 diesel engine fitted to the second prototype failed during its very first trial run due to a broken crankshaft, leaving the development team with no viable power plant for a vehicle whose entire concept depended on mobility. Recovering a broken-down Maus required 2 other Maus tanks, a self-defeating recovery doctrine that assumed production numbers that were never remotely achievable. Hitler approved production of 150 in May 1943. 2 incomplete hulls and 1 turret were the total output before Soviet forces captured the Kummersdorf testing grounds. The program consumed hundreds of thousands of man-hours of irreplaceable industrial capacity. It produced 2 vehicles that never reached combat, and a turret that ended up on a hull in a Russian museum. 14 vehicles, 30 years of German armored development, from the propaganda chassis rolled out for Norwegian newsreels in 1940 to the 188-ton vehicle that could not cross a bridge in 1944. The failure mode is consistent across every one of them. Engineers identified the problems. The problems were documented. The documentation was filed, and the vehicles were built anyway, because schedules mattered more than testing, because Hitler's birthday was a production deadline, because the war needed tanks faster than tanks could be properly designed. German engineers were not incompetent. The system they worked inside was broken in a specific and repeatable way. It chose ambition over evidence, complexity over reliability, and political preference over physical reality. The Maus never crossed a bridge. The Jagdtiger destroyed more of its own transmissions than enemy tanks. The Panther burned before it reached the enemy. The Ferdinand went to Kursk without a machine gun. The Panzer I went to Russia as a training vehicle. None of these were surprises. Every one of them was documented, reviewed, approved, and then sent to war. That is not bad luck. That is policy.